Part E.3, exercise question set number 6, the last video of part E. Let's look at the first question today. Here, I want you to compare two numbers, two expressions, very big expressions. But you need to be familiar with how to use logarithm correctly. So this one, if you want to try, so you can try before, look at my answer. Yeah. Based on my experience, not many students can do it correctly. So here, so let me show you. Yeah. First, look at this n. This number, 10 to the 10th. See? Yeah. All right, do not get confused. Yeah, for this expression. Let's evaluate these two expressions. Then we compare which one is larger. Yeah. First, if we take a log base 10, that should be relatively easy, right? Yeah. So let's do it. Log base 10 of n. So that's the log base 10 of 10 to the 10 to the 10th. Yeah. But we treat this whole thing as one number. Then log base 10 here for the exponent, or for the, the number, the power function, base also 10, right? The same base. All right. So then we have exponent number 10 to the 10th. That's pretty easy, right? All right. The B expression, this is A expression. Now let's look at the B expression. N to the 0.00001. How about that? It looks very small, but not really that small, right? So let's take a look. All right. 10 to the 10 to the 10th. All right. Then the number. So what's that number? What's that number? If we write 10 to the negative 6, right? 1 over 1 million. 1 millionth, 10 to the negative 6th, that power. Yeah. All right, so when we calculate this expression, base 10, then this base 10 to the 10th times 10 to the negative 6. How about that? All right, same base, very good, same base. Then we can simplify 10 minus 6. How about that? How about that? Okay, 10 minus 6, 4. 10 to the 10 to the 4th. All right, then 10 to the 4th, 10,000. How about that? 10,000. Compare 10,000 here, just 10. Which one is larger? Very simple, right? Very simple. How many of you can get this number? The hard part is this number. This one relatively easy. Yeah. Most of you can get that, but not many of you can get this one. Okay? Yeah. All right, so that's the first question. Second one. This one may not be very easy for you, yeah, but you need to use an important formula here. I mentioned in a previous video. Yeah. Here, let me give you this one. A log base A to the x equals x, this formula. Okay, all right. So what is the A? A positive, A not equal to 1, okay? If you have these two conditions, you can use this formula, okay? Yeah. How to see it? Yeah. Here, I can explain how to see it a little bit. All right. So if we don't know this expression, let's just write this whole expression as a y variable. All right. Then we take log base a both sides. Log base a both sides. Log base a of y equals log base a, this same base, okay? So we only have the exponent part, equals log base a of x. See, if you look at here, logarithm function, same base a, x and y, so y must be equal to x. So that's this one. Yeah. So we proved the formula. Now, if we use that, pretty easy, right? Yeah. Here, in that formula, a equal to 2, right? Yeah. So this equals n. Yeah. All right. So here, let's look at that. A equals root 2, okay, also equal to n. Yeah. Now the hard part is these two numbers, because the base different, 3e, e3, the base different. Yeah. Then, so let's do this. All right. Base different, can we use the same base, right? Can we write 3 as e to the log of 3? How about that? Use this formula here, okay? All right, yeah. Then 3 to the natural log n equal to e natural log n. How about that? Okay. Then use some property of exponential function e to the right? Okay, all right. Can we treat this natural log of 3 one number? Just one number, okay? All right. So can we write e n to the 3? How about that? Another property, right? This number we can put to that exponent part. Then apply this formula, a equal to e, yeah, because log base e, so this equals n to the 3. How about that? Okay, how about that? Okay, yeah. All right. Then C, you can use the same way there. Yeah. So let me just erase. I need some space here. All right. Yeah. All right. C e to the e, can we write that base 3 log base 3 e? Can we write that formula another time, right? So let me write here, x equals a to the x. Yeah. Here we use that formula again. Then e to the log base 3 of n, 3 log 3 of n. How about that? Then 3 how about that? Okay. Then n to that number. How about that? Okay. Log base 3, this same base, that a, right? So apply that formula, we get n to the log base 3 of n. How about that? Okay, all right. Now let's compare these numbers. For a, n to the first, d also n to the first. So we only look at the exponent number. For a, exponent of n, that's 1. B, exponent number of this power function n, that's natural log of 3. C, that exponent number, yeah, all right. E, right? E, okay, yeah, E, not n, all right. Typo, yeah. So log base 3 e, right? All right. And a d also 1. So we need to find the one largest number here. We know e approximately equal to e 2.71828. Okay, 2.7 something, all right? 2.7 something less than 3, right? So the base 2.7 something, then of 3, that should be greater than 1, right? Yeah. Here the base 3, e less than 3, right? So this should be less than 1, okay? So the largest one is natural log of 3. It's greater than 1, the largest number. So the answer is B. Can you get this one? This one is pretty hard. Yeah, it is pretty hard. So you need to repeatedly use this formula again, many times. And finally, you can get that answer. All right, so next question. So this one. For this question, given an array with 12 elements, what is the maximum number of inversions that the array can have? The maximum. Try your best to get the maximum number of inversions. First, you need to know the meaning of inversion, right? Meaning of inversion. Now, 2 elements, when we look at because when we look at one inversion, we look at 2 elements in the array. The value of the first one greater than the value of the second one, then they form an inversion. That's the meaning of inversion. All right. So here, we want to get a maximum number of inversions. So the question, can you create an example? So here the question. Can you create an example with maximum number of inversions? No. Then you get the answer. All right. So let's look at the situation of the maximum number of inversions. In that situation, any 2 elements in the array would give us an inversion. That's the maximum. Whenever you see 2 elements in the array, you get 1 inversion. That's the maximum. Okay? Yep. Any two pairs, any two elements as a pair give us one inversion. All right? Yep. So with that in our mind, here, let me write one example. 12, 11 in descending order, okay? Decreasing order, not increasing, ascending order. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? Any two elements in the array form an inversion, right? Yeah, any two, whatever you pick, one here, one there, the first one always greater than the second one, right? Because descending order. Yeah. Then you count how many pairs do you have, okay? You take the first element, then you form pair. First, then element, one of the remaining, all right? So 11. All right, so let me write this way, okay? Yeah. 12 something, this kind of inversion, there are 11, right? Yeah, because the star part, you can replace it by any of the remaining 11 elements. All right, next, 11 star, how many? 10, right? Yeah, because this time you don't look at 12, right? You only look at the elements after 11. And so on. 10 star type inversion 9. Okay? And so on. Yeah. So you keep doing that. All right? Then 3 star inversion 2, 2 star type inversion 1. Okay? 1 star 0, right? Because nothing behind the 1. All right, yeah. You add up all these numbers from 1 through 11. Okay, 1 plus 2 plus 11. Find this number. Use the formula 1 plus 11 times 11. Okay, yeah. 12, 6, 66. How about that? The answer, 66. Okay. All right, yeah. So that's our question number 3. Then the last question, number 4. Yeah. In this question, look at that big theta. Think about something I told you in the previous video where you see theta, big theta, 90% of the time you can use limit to prove it. This one, you can try that. It's pretty simple. Yeah. So let's do it. Okay. All right. Let's calculate this limit. Over 5th. Yeah. All right. After that, we take limit n minus 2 over n, whole thing to the 5th. All right. Then we simplify the fraction inside parenthesis 1 minus 2 over n to the 5th. When n goes to infinity, 2 over n, this fraction goes to 0. 1 minus 0, 1, 5th, 1. Positive constant, so therefore, big theta. Limit is a positive constant, then it must be in that big theta. Okay, so that's the limit way. Limit way. Okay, but there is a definition way. Definition much harder than this one. Okay, yeah, but there is a definition way to prove it. Okay, yeah. How to prove it, you can think about later. When I have a chance, I will show you how to do it. Because today we run out of time. I already near the limit of our standard time limit. So I need to stop right here. But later when I give you review for midterm, I can show you how to use definition to prove this. It's harder than the limit, but it helps you understand the concept, the big theta concept. So it is useful. Yeah. All right, so let me stop here. Yeah.